So I know you've balanced a bunch of equations before. I'm going to just go through a quick little review of how to do it, and then we'll go on to the challenging questions that you'll find in this book. Now, there's a few extra challenging ones right at the end. They won't be testable material, but they're very entertaining if you like this kind of thing, which I do because I'm a geek. Anyway, so chemical reactions, balancing them. This one is your classic example. I know I've probably shown this to you before, but I like it. So H2 and O2 creates H2O. In other words, hydrogen gas and oxygen gas makes water. Now, I've got two H's on this side, so hopefully you'll remember that the way that we balance these would be, I would write my H's and O's, and I have two H's and two O's on this side. And then I would write out my H's and O's on this side, and I would say I have two H's and only one O. Oh, well, that's a problem. So then, you know, every year I get somebody going, well, why don't I just do this? Now it's balanced. Well, sure. Also, you're dead, because you just turned water into hydrogen peroxide, which is deadly and will kill any living tissue that it touches, which is why it's really handy to have in your medicine cabinet, but not your mouth. So we leave the subscripts, that's what these little dudes are called, we leave the subscripts alone. We can't touch them, because that tells us what it is that we're dealing with. That identifies the substance. We don't change the substance. What we do is just count the pieces. So to count the pieces, we use coefficients. That's the big number in front. Now, to change that, I've got to go, okay, these guys are stuck this way. It's like they're little Lego pieces. They're stuck together. So I can't change them. All I can change is the amount of them that I have. So I know I need two of these guys. Now that's going to change the oxygen to 2, but it also changes the hydrogen to 4, because I have two H2s. So then I have to go back to this side of my equation. You're going to get this a lot, where you have to kind of go back and forth. It's fine. It works out in the end. I promise. Every single equation you have in this textbook works out in the end. So now I have 2 hydrogens, but I need 4, so I'm going to put a 2 in front of the H2. Note that I did not change what the equation is. It's still hydrogen gas and oxygen gas making water. I've just changed the representation of how many I have, because I've recognized that if there's 2 hydrogens for every oxygen on this side, there has to be 2 hydrogens for every oxygen on this side, which means I'm going to need twice the H2 gas that I have for the O2 gas to make it work out. Okay, that's a simple one. Let's try something just a little bit more challenging. Your textbook, page 107, has this equation. It gives us H2S, which any of you who've worked in the patch or been around it knows is a toxic gas, and lead chloride, also bad, lead bad, chloride bad, so this is not something that we would be playing with in the classroom, gives me PBS, so lead sulfate, and hydrochloric acid. So this is kind of a nasty equation. It looks simple, but like, these guys are nasty. H2S gas can kill you, lead can kill you, chlorine gas can kill you, and then they make acid out of it. Whee! So much fun. But all we have to do is look at it on paper and balance it out. So what we want to do is look at it and see if we have the same number of atoms on this side as we have on that side. The first thing we want to do is just identify which atoms we have present. So I'm going to list them all. And then I'm going to see how many of them I have on this side. So I have 2 H's, 1 sulfur, 1 lead, and 2 chlorines. On this side, I have the same ones, and if I didn't, then I wouldn't even be proceeding with this question. I'd be like, this is a junk question. It doesn't obey the law of conservation of atoms if they're not each on both sides. But they are. We got lead, sulfur, hydrogen, chloride. They're just matched up a little differently. So I have one hydrogen, one sulfur, one lead, one chloride on that side. Clearly, we need to do something to this side to match it up to this one, because this is the one with the bigger numbers. Now I notice that, handily enough, H and Cl are together, which means that I have to double my H and double my Cl, so I put a 2 there. That's going to double my H, double my Cl, and oh, look at that. That's all we had to do. It's balanced already.